good morning, good afternoon, good evening to everyone present over here. Hope you all are doing well and staying safe. Greetings from the team Petroleum Engineers Association. I am Niharika from Team PEA. Welcome to this 2 days fundamental workshop on well completions, wellheads, and Xmas trees agenda by Sir Ibad Siddiqui, IIM UK certified trainer. Thank you all for joining in this workshop. Now, without wasting any further time, I would like Sir Ibad Siddiqui to start this fundamental workshop. Thank you. Over to you, sir.
Um, Thank you very much, Ms. Niharika, and really grateful for Petroleum Engineers Association for this wonderful opportunity for me to contribute towards the industry and to share my knowledge with anyone who would like to gain that. Uh, Welcome, everyone. Thank you very much for participating here. And I would like to welcome you all on behalf of PEA. Today we have gathered for a fundamental workshop on the topic well completions and wellheads and Xmas trees. So it is basically a 2 days workshop. We have divided the topic on in topic wise in the days where we will discuss in detail the well completion tools and accessories. And then the second day, I've assigned the topic of wellheads and Xmas trees. So starting with a little bit of rules for the workshop, where everyone has to keep their mics on mute, please. If any questions or any concern regarding my voice clarity or any concern regarding if I'm going very fast or I'm not audible enough, my pronunciation is not clear enough, so just use raise hand button. Follow your respective emergency exits wherever you are, in your home, at your office. Just follow the respective emergency rules. And all the questions will be entertained at the end of the session so that we can cover the assigned topics in the allocated time. So just to ensure that. So welcome to day one, everyone, for this fundamental workshop. Let's start. So for the learning objectives, why we have gathered here, what we are going to learn, the objectives. So we'll start with well completion. What is well completion? We'll go later on to learn more about the well completion tools and accessories. What are the various tools available in the market? The functions, we'll learn about functions of the completion tools and accessories. The placement, the correct placement, we'll be trying to analyze why a certain completion tool is placed at a certain point in the completion assembly, and then the correct sequence of using it. So let's start with what is well completion. I would have loved to gather some input from the participants, if possible, Ms. Niharika. Is it? What is by definition? It is the activities, the collection of activities and methods of preparing a well to produce oil and gas or for any other purpose, such as injection. The method by which one or more flow paths for hydrocarbons are established between the reservoir and the surface. So that is a compact and concise definition of well completion, what we exactly do when we say we are going to complete the well. So let's suppose, starting from a casing program, let's suppose we have a generic casing program where we have a 36 or a 30-inch conductor in the well. After that, we have ran surface casing of 20-inch, then the intermediate casing of 13 through 8-inch, We have a production casing of 958 inch, and then we have a 7-inch liner. That's a typical, normal, conventional well configuration and casing program. So after we have achieved this milestone in our in drilling a well, we will go towards the well completion. So starting with the first tool from the bottom, I'm starting from the bottom so that we are taking into consideration the sequence or as well while learning about the tools. So keep in mind, everyone, we will be going ahead with the correct sequence. The sequence we'll be using, we'll be learning along with learning about the tools. So starting with right at the bottom, wireline reentry guide. What is a wireline reentry guide? So wireline reentry guide generally takes one of the two forms. First, it could be a bell guide, and then the other one, a mule shoe guide. So there are two types available. What is a bell guide? A bell guide is having a 45-degree lead in taper to allow easy re-entry into the tubing of well intervention tool strings for actually accommodating the well intervention tools and the slick line. When we call about well intervention, it is slick line, it could be E-line, and also the coil tubing. So those tools, when we enter and make an entry to the well, this tapered shape right at the bottom ensures and helps us to get our tools back inside the tubing. This guide is commonly used in completions where the end of the tubing string does not need to pass the top of a liner hanger. Let's learn about a little bit about a mule shoe guide. What is a mule shoe guide and what is the difference? So the mule shoe guide is essentially the same as the bell guide, but except for a large 45-degree shoulder. It has a cut shoulder. It's almost the same as the bell guide, but it has a cut shoulder to ensure at a more certain degree to ensure that the tools we have ran in at a certain depth outside the tubing, we can make sure that all the tools with all the ODs and different ODs can come back into the completion safe and sound without any getting stuck. The tubing land on a liner lip while running completion in the well. The large 45-degree shoulder should orientate onto the liner lip and move the tubing into the liner. So the next one, what is a production tubing? Production tubing is actually a single length of the pipe to provide a conduit through which the oil or gas will be produced from a wellbore. The tubing joints are generally around 30 feet or 9 meters in length with a thread connection on each end. The material specification of the tubing, the geometry, the design of the connection threads are selected according to the expected reservoir fluids and the wellbore conditions. Let's learn a bit more about production tubing. So the size, it refers to the outside diameter in inches or millimeter, or the tube body itself. It is available in various external diameters where API recognized sizes of production tubing vary from the minimum of 3/4 inch to a maximum 4.5 inch. When we talk about weight of the production tubing, so it is an average given in pounds per feet, and various weights are available in the market. The grade, the term is used to describe the type of the metal alloy of which the pipe is made of. For example, it could be a J55, it could be an LAT or an NAT or a P105. And then the fourth one, it's a thread connection where it is actually the design of the connection on either end of the pipe. Moving on, what are the nominal sizes and the weight per foot for the production tubing? So usually and most commonly used tubing sizes are 238, 278, 3.5, and 4.5. And 5.5 is one, or 4.5 and 5.5 are mostly used in the gas well, where we have more, where we have to ensure more dia is there. to ensure that there is no turbulence and there is no corrosivity. So moving on, these are the grades. When we talk about J55 or an LAT on an NAT or P105, it is actually talking about the yield strength of the tubing. An AT refers it as a 80 KSI yield strength, which is a minimum for the production tubing of that particular type. So what is a pup joint? Because I wanted to tell you guys that just above the Wireline reentry guide, we actually install a pup joint. And to come to a pup joint, I wanted to let you guys know about the tubing, production tubing. So this is actually a short length of the tubing, having the same specifications as of the tubing to be used in the completion string. A short length of pipe, the same tubing, just keep in mind, because it provides a flexibility, the availability, and in attaining a desired tubing length in the completion assembly. So here, the basic purpose of using the pup joint at this particular place, just above the Wireline reentry guide, is to provide a length or a housing to refrain from letting the pressure gauges hang from the bottom no-go nipple outside the completion string. When we actually set the hanger with the pressure gauges in the nipple, we actually want to save the pressure gauges from the shaking, from the twisting. So we keep this pup joint between the bottom no-go nipple and the Wireline reentry guide to ensure that the gauges are not outside the tubing. So next comes above the pup joint comes the landing nipples. What is a landing nipple? A short tubular device with an internally machined profile used for various purposes. What could be those various purposes? It could be used for plugging the tubing, for removing the wellhead of service equipment, plugging the tubing, installing plugs for pressure testing, installing plugs inside the nipple for setting hydraulic set packers, or it could be used for zonal isolation. Other functions and applications of landing nipples are installing downhole chokes, regulators, triple SVs, and we can install the bottom hole pressure gauges in those landing nipples as well. So we were talking about generally about the landing nipples, but here the bottom no-go nipple or R nipple for Baker and XN nipple for Halliburton brand. So the bottom no-go nipple just above the pup joint, it is installed to incorporate a reduced diameter internal profile that provides a positive indication of seating by preventing the tool or device to be set from passing through the nipple. The restricted internal diameter created by the no-go profile provides the seating and positioning of variety of devices. So this is actually the least ID, the minimum ID throughout the tubing, throughout the completion string. So it is one of the most important information, the minimum ID of this bottom no-go nipple, to have this information throughout the well intervention and the completion procedures and operations. Just keep in mind, only one no-go nipple of a particular size is used in a well, where it is usually placed at or near the bottom of the well below the other nipple. So we are using it here at the very bottom, just above the pup joint, and the pup joint has its own purpose. Otherwise, we would have connected it directly to the Wireline reentry guide. So this is the bottommost nipple for us in the completion assembly. Moving on, there is a perforated pup joint. So we talked about tubing joint, we talked about what is a pup joint, and then there is a perforated pup joint. So why does, what is the function of it? The perforated pup joint is actually used in the completion string for the purpose of providing the bypass flow. The bypass flow if bottom hole pressure and temperature gauges are installed in the bottom no-go nipple for reservoir monitoring. So this is a particular perforated pup joint having the same specifications of the tubing used in the completion assembly and also the pup joint. But the main difference is that it's perforated. It has holes in it. And the design criteria of the perforated joint is actually the total cross-sectional area of the holes should be at least equivalent to the cross-sectional area corresponding to the ID of the tubing. So we have to calculate the total cross-sectional area of the holes according to the total cross-sectional area available in the tubing, because we have to make sure that if the gauges are installed in the bottom no-go nipple for reservoir monitoring, the flow does not get a restriction. The flow gets a normal flow where so that we can have a proper measurement of the reservoir parameters and the wellbore parameters and the readings and the measurements done by the pressure gauges and the temperature gauges are correctly measured. Moving on and moving up, actually, top no-go nipple, it is actually the same short tubular device with an internally machined profile with exactly same material specifications as of the bottom no-go nipple. So the basic purpose is to provide an internal profile for the plugs. So the plugs are installed in the top no-go nipple and the pressure gauges are installed in the bottom no-go nipple. Just remember that. And I have used F for this for the Baker brand. They have a patent on that, and the Otis tools are called X nipples. Moving on, landing nipples. So the basic difference here will be this is an X landing nipple, you can see here, and this is an XN nipple. So this becomes a top no-go nipple, and this becomes a bottom no-go nipple, where if I would not cut that out by appearance and from outside, it looks both the same. But from inside, if we can see the inside of the cross-sectional cut there, it has a normal profile here. And the bottom no-go nipple, the XN nipple, XN means no-go ID it has. So there is a no-go shoulder, which you can see here. And the seal bore area is same, the key profile is same, the size is same, the material specification is same, but the basic difference is the minimum restriction ID available in the bottom no-go nipple or the XN nipple. So again, we will install another pup joint here above the top no-go nipple. And the purpose of using this at this place is to provide a length to be perforated and flow path to be restored in case a plug in the top nipple gets stuck and cannot be retrieved. So this pup joint will help us to get the flow back from a well if a plug for installed in the top no-go nipple for any purpose gets stuck. There are a lot of examples where a plug installed for a purpose and then the purpose is fulfilled and then you have to retrieve the plug back and the plug gets stuck. You find it stuck in the nipple. So in that way, with thinking and making the plan for getting the plug retrieved safely and effectively, we have to have this accommodation and an option to get this pup joint perforated to at least ensure that the well comes back to flow, and then we don't have a panic situation that a well is shut in just because a plug is stuck inside the nipple. Moving on. Now, above this pup joint, we have a mill-out extension. So let's learn about mill-out extension. What is a mill-out extension? So it actually provides a large ID below the packer seal bore, which allows a single trip packer milling tool to be used when the tubing is run below the packer assembly. So it actually provides a larger ID below the packer. So it actually helps us. This additional length And the ID is necessary to accommodate a standard milling tool. So when we have to retrieve the tubing, when we have to retrieve the completion assembly, the tail assembly, for any workover or any kind of problem we have encountered in a well. So we use a single trip packer milling tool where it has a small hanger uh, attached to the milling tool, which actually the upper part, the mill actually mills the packer element, and the hanger tool will will actually hang and will bear all the load of the completion tail assembly after the packer is milled, and the tail assembly gets free from the well. So mill out extension is actually installed for that purpose. Then comes a seal bore extension. What is a seal bore extension? Above, we will install it above the seal bore, above the mill out extension. So it actually extends the effective packer seal bore. The packer seal bore, I'll come to that a little bit later. So it is actually used where excessive tubing expansion or contraction is anticipated. It is used to provide an additional sealing where sealing bore area when a long seal assembly is run to accommodate tubing movement and has the same ID as the packer. So it actually, a packer has a seal bore for the locator seal assembly. And I'll come to those tools a little bit later in the same presentation. So the packer seal bore provides a seal bore area for the seals of the locator seal assembly to ensure the proper sealing for well integrity. So I'll come back to it a little bit later when I'll be explaining the packers and the locator seal assembly. So this will be better understood in that way. So moving on with the packers. What is a packer? One of the most important tool inside the completion assembly. So we have 5 different kinds of packers. It varies from the setting method, the purpose of it, the tool length, the specifications, the dias. So these are the 5 basic types of packers available. So if we talk about the production packer, it is actually a completion tool where it is used to provide a seal between the casing and the tubing in a well to prevent the vertical movement of fluids past the sealing point. So it is actually providing a seal between the casing and tubing, the basic seal providing between the casing and the tubing. And actually, in other words, it is actually providing a seal between the production, the well and the annulus. So allowing fluids from a reservoir to be produced to surface facilities through the production tubing. So it is actually making that seal, which is an absolute necessary thing to have for ensuring the well integrity. And this seal is absolutely necessary to differentiate between the well and the annulus. So what are the basic functions of production packers? So if we talk about production packers, it actually prevents downhole movement of the tubing string because it has a seal. So the tubing along with the contraction and compression, the tubing keeps on moving up and down. So it actually provides a prevention of the movement. It actually supports some of the weight of the tubing where there is a significant compressive load on the tubing string. So when the hot fluids are produced, the metal expands and the tubing tends to move, and this packer bears a certain amount of load which is exerted from the upper completion on the tail assembly. It also holds the well servicing fluid like kill fluids or the packer fluids in the casing annulus. So when we talk about making the seal between the annulus and the well, it actually gives us the support, and it actually makes the sealing perfectly so that to hold the servicing fluids and the kill fluids, and for using later on in the well intervention as well, when we pump in different fluids, or when we are trying to treat the annulus at a certain point of the life of the well. It protects the production casing from corrosion, because the casing has to be protected to ensure the well integrity throughout the life cycle of the well. And the corrosive fluids, the reservoir fluids, if the packer is not sealing properly, the corrosive environment and the corrosive fluids will go inside the casing, and it will, at a certain a point of time, it will start corroding the casing, and that will make our life a lot worse, and that will create a lot of well control issues and well integrity issues. Then, if we talk about the packer functions, it also facilitates the separating multiple producing zones, and also it facilitates the artificial lift, such as continuous gas lifting through the A annulus. Moving on with the functions, here if you can see when I was talking about protecting the casing, so just as a scenario, we have a reservoir here and the completion here, and I'm showing it as a tubing, and I'm not showing any jewelry of the completion here, just for understanding purpose. So if the packer is not there and tubing is just like this, so the reservoir fluids will be going in to the casing, and the casing will be in contact with the reservoir fluids. But when we install a packer here with the completion tools, so it actually ensures that the casing is free from the reservoir fluids contact, and the flow directly is produced with a good energy towards the surface, and the casing can be intact without any corrosion issues. And this annulus has to be kept with a corrosion inhibited packer fluid or a completion brine, so to ensure that the casing does not get corroded throughout with the life cycle. So moving on, let's learn about the types of production packers. The production packers are classified into retrievable packers and permanent packers. There are two kinds of packers and categorized into the method of setting them. One is retrievable and the second is permanent. So let's try to learn about the retrievable packers first. So retrievable packers are actually run on wireline, E-line, or tubing. It may be set mechanically or hydraulically. It can be usually removed from the well by the application of mechanical forces, and the main advantage is to retrieve without destruction. So temporary or a retrievable packer is actually installed to, if we have a plan to retrieve it at a certain point. Most of the times when drill string testing or a DST is run, that the completion of the DST, the completion assembly of the DST is run with a temporary packer where it is set and retrieved at a certain point, and this is done through a retrievable packer. Moving on, let's learn about permanent packers. So it actually incorporates a seal bore that accepts a seal assembly fitted to the bottom of the production tubing. So this, when we talk about permanent packers, it can be set hydraulically by applying pressure on the tubing or a drill pipe set, and it can be set by electric current short on E-line as well. So it has both the options still, but mostly it is set on the wireline to ensure the packer is set accurately on the depth with a proper depth correlation, so that we ensure that it is not set on a collar of a tubing or a joint of a tubing, and we ensure that this packer setting depth is in the middle of any tubing joint, wherever it is set. And it can be retrieved only by milling. So that's why it is called permanent packers, because it cannot be retrieved without milling, and milling needs a rig and a rig workover for that purpose. So let's talk about a little bit of comparison between the permanent packers and the retrievable. So there are some advantages for the permanent packers. It has a performance envelope. It has generally higher pressure ratings where it is deemed necessary to use the permanent packer, where we have a higher pressure rate, pressure envelope, and we need higher pressure ratings. For permanent packers, the packer to tubing seals are retrieved without packer, and it holds pressure from above or below without set down weight or tension. But if we talk about the disadvantages, it has to be milled over to retrieve, and it cannot be used again. So this is one time use, and it cannot be retrieved without milling. If we talk about some advantages of the retrievable packers, it can be retrieved without milling, of course. It can be used again with a little bit of redressing of the seals, little bit of cleaning of the tool, and then it can be resettable again. But the disadvantages, it is normally retrieved on production tubing. It is generally have smaller IDs in the wells where we have a high rate, flow rate, or a high pressure. The retrievable packers are deemed limited, and it has a lot of limitations as far as the IDs and the lower pressure ratings. So in those cases, we generally go towards permanent packers. Moving on with the production packers, there are some real pictures where it is actually a retrievable packer lying in the warehouse, ready to go to a well. So actually, when we talk about the parts of a packer, so this is actually a casing of the packer. This is actually the casing of the well, and the packer is set here. So the seal element you can see in the packer is here. This is the main sealing element, which is actually holding the whole tail assembly against the casing wall. And these are the slip anchors, which actually provides a support and the basic locking mechanism of the packer against the casing. When we say a term, the packer is set, actually the slip anchors, the slips are actually taking a bite against the casing, which ensures the proper holding of the packer against the casing, and the sealing element actually ensures that this part actually creates a good seal to ensure that the casing annulus and the production tubing and the well creates an isolation between them. So learning about the components a little bit more, the slips, when I talk about the slips, it has a tooth-like parts outside the packer. You can see here where it forces outward by setting action. It actually prevents the up motion and the bottom for down motion. So up slips prevent the up motion, and the down slips prevent the down motion. So it actually creates a double barrier and a double insurity that the packer remains intact and holds good against the casing wall. And the packing elements, these are the packing elements when they are not on the packer. They are nitrile rubber elements for normal pressure temperature conditions, and the different kinds of material such as elastomers are used for high pressure, high temperature conditions. And it actually provides seal between, this is the part which actually provides the seal between the casing and the tubing. So these are the slips and these are the packer elements, packing elements. and this is your packer. Moving on, so here the tail assembly is installed, is right there intact inside the casing, and it holds from the packer, and the tail assembly is hanging from the uh, uh, packer itself. But let's start from bottom for the upper assembly, the upper completion assembly, where we start from the locator seal assembly, which goes inside the packer. So it is a configuration of seals arranged on the component that engages in a seal bore to isolate the production tubing conduit from the annulus. So it actually has a sealing element, it has a mule tube guide, it has a locator. So these seals go inside the packer, and the packer has a seal bore, which these seals are creating a seal between the well and the annulus in above the tail assembly, and these seals are actually creating a seal against the polish bore. So we have to ensure that the polish bore inside the packer is intact, and it is not uh, inside the packer bore is there. So this part it has a polish bore inside. So when we talk about the polish bore, it is actually there for the ensuring the locator seal assembly seals are creating a good seal against that. And if while operation or by manufacturing, the seal bore is not shiny enough, or is not in a proper condition, these seals of locator seal assembly will not hold pressure and will not seal. The seal assembly is typically longer than the seal bore to enable some movement of the components while maintaining an efficient seal. So with the flow of the production fluids throughout the well life cycle, the tubing, the upper completion keeps on moving up and down with the compression and expansion according to the temperature environment of the well. So the sealing elements, you can add 3 or 4 or whatever is necessary according to the length and according to the depth of the well. We have to keep this length of sealing elements a little bit more than the seal bore of the packer, so that if it moves up and down, at least some part of the seal is ensured to be inside the polish bore and creating the seal which we need for that. And talking about the seal bore extension again, so now we know that these seals from the upper completion actually creates a seal against the polish bore, and to extend the seal bore of the packer, we actually install a seal bore extension below the packer, so that the seal bore area is extended for the locator seal assembly, the sealing elements of the locator seal assembly, to ensure the sealing against the polish bore. So this is the basic method and the basic criteria of having these 3 tools in that sequence. The locator seal assembly is run in the well on the production tubing until it no-go shoulders locates. So this is a no-go shoulder, and it actually locates on the top of the packer. So we have an indication when while running the completion, the upper completion, we get an indication of this shoulder, the locator it is called. That's why it has a name of locator seal assembly. So this is a locator and this is a seal assembly. So this gets a name of locator seal assembly. And this locator, the shoulder of the locator actually sits on the top of the packer, so that that gives an indication at the surface that the locator seal assembly is actually set and it has actually reached the desired depth of the packer, and the seal bore element, the sealing elements are against the polished bore of the packer. So this gives us that surety, and that gives us the indication. So this positions one or more seal stacks in the packer's seal bore and establishes a seal between the packer and the tubing. So this ensures, the locator ensures the depth, the correct depth we have reached, and that we have set the locator seal assembly and the upper completion correctly, and the sealing elements ensure the sealing between the annulus and the tubing itself. So there are four parts of the locator seal assembly, starting from bottom again, half mule shoe, which is ensured for any, which is actually the bottom of the upper completion assembly. Then it has a seal units. So this is the half mule shoe. These are the seal units here. Then it can have a spacer on an extension seal assemblies to ensure the correct length of the locator seal assembly is used to ensure that the packer seal bore has the sealing elements inside and the locator sits right at the top of the packer. And then there is a no-go locator or a shoulder. So this is called a locator in the locator seal assembly. Moving on and moving up, we have one of the most important tools we can have in our completion assembly. It is called sliding sleeve door. So what is a sliding sleeve door or a sliding side door? It actually is a communication tool. It allows the controlled communication between the tubing and the annulus. So it actually consists of two concentric sleeves. You can see here, this is a seal inside. It is a cutout for explanation purpose. So this is an inside sleeve, and this is the exterior of the SSD. So these, it both has ports, open ports, where the inside sleeve has a ports up and down, and these, the exterior of the exterior body of the SSD has these ports here. So it actually ensures that that the communication is achieved at a controlled amount wherever necessary, and the inner sleeve can be moved. This inner sleeve is movable. It can be moved with well intervention tools such as slick line or a coil tubing. Downhole through tubing tools are usually wireline, but we can do it with coil tubing as well to align the openings to provide a communication path for the circulation of fluids. So when the openings of both the sleeves are aligned, it creates a communication which is required at any point, wherever necessary, so to ensure the communication between the tubing and the annulus. And when these openings, these ports are not aligned, it actually creates a lock, and this SSG is deemed closed for the well to have a production in normal way. Moving on, what are the usual SSD applications? So what kind of purposes we can achieve, what kind of accomplishments we can have using the SSD. So it is usually used to circulate a less denser fluid into the tubing prior to production. Then it is also used to circulate appropriate kill fluid into the well prior to workover. So if we have to do a workover, we have to kill the well. And if we have an SSD inside the well, it is used to provide the communication from the annulus in the tubing, and we pump kill fluid in the well bore to kill the fluid so that a rig can come up and do the workover. As a production device in a multi-zone completion, it can produce it can ensure the communication at a certain zone where the lower zone is produced below the packer, and this SSD will always be installed above the packer at any point where an upper zone can have this availability and feasibility to be produced at any point where deemed necessary, just by opening the SSD, and we can have a commingled production in that case. It can be used as a contingency if tubing or a tailpipe plugging occurs. So again, when we discussed about the perforated pup joint, so it was used as a backup for in a case where the nipple gets stuck and the nipple has a pressure gauge, the bottom no-go nipple has a pressure gauge installed there. So in this way, having an SSD can have a plan B or a plan C in case the tubing gets plugged by a scale, by any fill, by sand, and this can make our life a little bit easier at a certain level so that we can open this and we can have a certain amount of flow for a well, and the flow does not get shut in and that does not get hold up. It can also be used as a contingency to equalize pressure across a deep set plug after a pressure integrity testing. So when we actually pressure test the tubing for integrity, we actually install the plug as we have learned earlier. So the plug deep, when it is set deep, the pressure equalization is an extremely important part when the plugs are set and retrieved. So if there is a plug set down there in the well bore, it has a pressure differential which could be at any level. So the shut-in pressure is a hold below the plug, and we have a lesser pressure or a zero pressure above the plug. So it for the plug to be retrieved, we need some level of equalization, and for that equalization we can have a contingency of having a SSD, and when we can use that. And it also assists in the removal of hydrocarbons below packers in some cases. So the SSD, we have two concentric sleeves as we learned here. So this is the exterior and it has open ports, and the inner sleeve has its own ports again, and it both has a sealing element between them. So when we talk about the open position, the SSD is open. So both the ports of the sleeves will be against each other, will be coinciding, and it actually ensures the open path between the two concentric sleeves, and the path is open for communication. And if the same sleeve ports are not aligned with the outer sleeve, so it gives us a closed position. And in this configuration, we actually call it that the SSD is in a closed position. So inner ports are not aligned against the outer body ports, and the seals are always there to ensure that there is no leakage among the desired openings. So this is something how we can learn that the concentric sleeves work when the sliding sleeve door is there in our combination assembly. And this movement, this shifting can be done through slick line or a coil tubing. We use specific shifting tools for shifting this inner sleeve, and it has a particular size. The sleeve has a particular size, and this SSG has a specific and appropriate designed shifting tools, which is connected to the wireline tool string, and we make sure that it is opened or closed as per requirement. So moving on, we have a side pocket mandrel. So what is a side pocket mandrel? As you can see in the picture, it can be used. It has a little bit odd shape, which actually is not creating any kind of restriction in the well bore, and it has a bubble shape outside the tubing, OD, which is used to install gas lift valves. It can be used to install chemical injection valves. If it's not in operation and we don't want to use that as PM opening, so we can install a dummy valve. so that there is no leakage or there is no opening and communication. And then we can use it for well killing as well. So trying to learn about the SPM. So this is an SPM and we are using it for communication for any purposes we just saw in the last slide, where we, if just suppose if we want to inject any chemical, so we install a chemical injection valve or a gas lift valve like this. It has a rope socket above for the slick line tool to catch it and install and retrieve it inside this port. So this is an SPM and this is the port where this chemical injection valve or a gas lift valve will be installed. So this in this way we pump the gas or a chemical in the annulus, and at a certain operating parameter, the gas lift valve actually starts opening. It has a spring inside, and that which is ensuring that this operates at a desired pressure or flow condition. So this is, just suppose this is a gas pump and gas supply pump, and this is supplying the gas inside. So it will only open at a certain design parameters for design for a certain gas lift valve, and this is set and retrieved inside the SPM port through slick line. Moving on, so we have a flow coupling. What is the purpose? Flow coupling is actually a short section of a thick walled pipe coming in 2 to 4 feet lengths and with the tubing threads at the end. So it has a thick wall, but the same material specification, but the wall thickness is more than the normal tubing. But the tubing threads, the connections of the pin and box connections are same to ensure that there are no crossovers needed. So the thread connections should be the same. But what is the purpose? So it is installed at the points in the tubing string where excessive turbulence is expected. So above and below crossovers, above and below landing nipples or an SSV. So any kind of restriction or a lesser ID actually creates turbulence in the flow. And the turbulence cause a certain amount of abrasive action or an abrasion towards the tubing, where just after that restriction, it creates a turbulent flow, which is, if not a flow coupling is not installed against that, the normal tubing wall thickness will get eroded very quickly, and it will create well integrity issues for us to deal with. And so it is installed above and below the restriction to act as flow straightening devices to protect against abrasion. So we have learned that it will be installed above and below the minimum restriction tools like landing nipples or a crossover or a triple SV, so that to ensure that there is the abrasion, the abrasive effect does not make erosion to a normal tubing wall thickness and does not create any holes or parting of tubing in the well, which will create a communication within annulus, and it will create a well control issue, and it will create a SAP. The additional wall thickness actually prevents the early failures due to the erosion and in the turbulent flow area. So when we talk about flow coupling is actually a thick wall, as I said earlier. This is the same connections. It is connected to the tubing, which has a lesser wall thickness. But one thing to note here, that the inner ID, the inner diameter is exactly the same, which will ensure that there are no restrictions using a greater wall thickness in the well. The wall thickness will be outside of the OD will be higher, the OD will be bigger for the flow coupling, but the ID remains intact and the tubing does not have any difference in the ID. So in case of a landing nipple, it has a restricted profile. So if the flow actually is taken as a flow from a producer, so the above and below it will create turbulent flow, and this flow coupling will ensure that the abrasive effect and the erosion does not get the tubing eroded and making a holes inside the tubing, and it will have a better response to the turbulent flow within the wellbore. So this will create turbulence while producing, and the tubing is a normal ID, normal thickness, and the flow coupling installed above and below the restricted tools has a better and a better response to that turbulence. So coming on the downhole safety valves. So as I see that we are almost done with our 1 hour allocated for today. So